Example 6 is a really cool problem related to an equilibrium. And so with these equilibrium type problems, what we want our resultant vector to be is 0, 0. Or if you're doing this in 3 dimensions, it would be 0, 0, 0. But this case is just 2, I think. Okay? So let's draw this together. And we're going to do force 1 at 315 newtons. And I'm just going to draw that in the positive x-axis. It's kind of nice to start there. So that's 315, and that's force 1. Force 2 is at 218 newtons, and the angle between forces 1 and 2 is 155. So let's see here. We've got 218, so a little bit smaller than that one. And that's 218 newtons. That angle is 155. Okay? And then force 3 is 406 newtons, and the angle between forces 2 and 3 is 98. So this angle between these two is not exactly right. It would be 98. And that's force 3. And I probably shouldn't have written this because this is not an equilibrium problem, I guess. This is actually just figuring out what the magnitude and direction of the total force is. So hey, how about we scratch this from your brain, and we just want to find the magnitude and direction of the total force, which is the resultant. When I had mentioned this resultant vector being 0, 0, that's if you don't know, the direction here, and then the force. So for this one, we're going to set up these 3 different forces, and we're going to add them all up. So force 1, we need to find the x component. So for force 1, the x component is 315, and the up and the down is 0. Kind of nice to use the positive x-axis when you draw these. Don't have to, but it's kind of nice. Force 2, remember the x component is going to be the magnitude, and then we're going to do the cosine of the angle, which is 155. So it's negative 198, approximately. And then we could also do the sine, which is 92. And then we'll do a different color here for the next one. And the next one, even though the problem says 98, we're going from the positive x-axis, so we're not going to use 98. What we're going to have to do is add 155 and 98, and that's 253. So our force is 406, and we're going to do the cosine and then 253. So this is negative 119. And then we can do the same thing with the sine. That'll give us our y component. So that's negative 388. So all we need to do now is add all of these up, and that'll be our resultant vector. And then we can find the magnitude and direction there. So we'll do 315 minus 198 minus 119. That gets us to negative 2. And then we'll do 92 minus 388. That gets us to negative 296. So if you plotted this one, we actually don't know the magnitude yet, but we would be left 2 and then down 296. So that might be, something like that. That should be left a little bit, I suppose, right there. But the actual force that's on this object is it's pulling it in this direction. We want to know what the actual direction is and the magnitude. So the magnitude, remember, that's just the square root of the x value squared. It's going to be really close to 296. This is almost straight vertically down there. So we can type that in and see what it is here. So we'll do 2 squared and then 296 squared. And the magnitude is about 296, and that's in newtons. This one's a little tricky, but if you remember finding the angle from polar, what we did is we used the inverse tangent because we have a y and an x. So we'll do negative 296, the inverse tangent, divided by negative 2. And we'll see what that is. Now remember for this one, so theta is equal to the inverse tangent of y over x. And this one, this gave us roughly 89.6. But we know that it's not here. We have to add 180. So whenever that angle is in quadrant 2 or 3, we have to add 180, and we've got about 270 degrees. So there's your direction.